It was my 16th birthday. I waited all year along for this one perfect evening. The lights were up, the lanterns dancing on the fence, a small speaker playing my favorite song, friends on their way. The sky looked peaceful. This birthday is going to be magical, I felt. And then, everything changed. The clouds arrived without warning, the wind howled, the lights flickered, and then came the sound. Speakers off, cake ruined, dreams drenched. I sat by the window, still in my party dress, my eyeliner smudged, my heart heavy. Outside, pitch black. And then it happened. A sudden light tore across the sky, followed by a deep crackling sound that shook my chest. The kind of sound that you feel, not just hear. I jumped back, wide-eyed. That wasn't just rain. That's light. That's sound. The sky felt alive. What was that? I thought. The party was over, but my curiosity had just begun. This made me rush into my father's old study, the room in the house that still smelled like books and thunder. I pulled down a physics encyclopedia, flipped pages, stomped at a word I'd only skimmed before: static electricity. The words stared at me, static electricity. I read loud. Electricity is the movement or transfer of electric charges. So, these charges live inside the objects? And sometimes they move from one body to another? I thought. Is that what happened to the clouds? One cloud had more charges and it couldn't hold them anymore? Did the lightning just give them away? I flipped the page and it shook my entire mind. Come, I'll explain you. Everything, you, your chair, the clouds, is made up of atoms. Atoms carry positive and negative charges. Most of the time, these charges are balanced. But sometimes, one object rubs against another. It steals electrons. Now, one object has extra charges and other has less. Charges don't like imbalance. When one object is overloaded and other is craving balance, nature doesn't whisper, it reacts dramatically. Okay, picture this. You are carrying everything. A school bag, a lunch box, water bottle, math project, and for some reason a pillow. Your arms ache, your patience is gone, you are done. And then you spot your sibling walking towards you, empty-handed, swinging their arms like they are on a fashion ramp. Something inside you snaps. You don't speak, you just move closer and start dumping the stuff. First goes the pillow, then the bottle, then half the bag. Why? Because you couldn't carry it all. Because they had space. Because balance need to be restored. That, my friend, is exactly how charges behave. Charges don't enjoy being crammed into one object. If they see another object nearby with room to spare, they don't need to be invited. Even without touching, just coming close enough is sometimes enough. The charges feel the imbalance and they merge. They rush, fast, wild, unstoppable from the overloaded object to the one that's ready to receive. And that sudden movement of the charges, that's electricity. More precisely, static electricity. So now you are wondering, how do charges actually move from one object to the other object? There are usually two methods: conduction and induction. Conduction is the dramatic kind. When two objects touch in which one has an extra charge and other has less, what happens? The one with the extra charge behaves like, here, take it. I can't carry this anymore. Like you dumping your school bag on your sibling. No asking, no apology, just full transfer. It's contact transfer. Physical, obvious, very, very touchy. Now comes the weird one, induction. In this case, no one touches. They just come close. Like that Sharma auntie trying to casually compare her son's marks with you at a wedding. She's not even in your personal space yet. But you already rearrange your face, your tone, your entire vibe. That's exactly what happens in induction. One charged object comes close to a neutral object, and the charges in the neutral object go like, oh, a negatively charged visitor. Fine, I'll rearrange. So all the opposite charges gather near the visitor. The like charges move away. No touchy, just a complete internal drama of rearrangement. So remember, conduction is like hugging and transferring stress. Induction is like silent judgment causing emotional derailment. Both are real, scientific, and super cool. Now you might wonder, where do we even experience all this in the real life? Oh, we do more than you realize, dear. That little shock you feel when you touch your friend's elbow after walking on a carpet. Static electricity. Free electrons from the air sneak onto your friend's elbow, and the moment you touch, zap, they transfer to you. No magic, just science. And not just that, we humans use this knowledge too. Ever wonder how a printer gives such a sharp, perfect letters on paper? Or how a luxury car gets those glossy paint coats? In laser printer and electrostatic painting, we use the exact same idea. First, we give a surface negative charge. Then, we spray it with positively charged ink or paint particles. And naturally, opposites attract. The particles stick in clean, precise pattern. And now comes the grand finale of charge transfer, lightning. What happens up there in the clouds? Well, as clouds move, they rub against each other, charges build up. Some clouds become heavy with electrons, overburdened. They look for relief by transferring charges to another cloud or to the ground. But there's a villain in between. Air. It's not very supportive of easy charge transfer. So, when the pressure gets too high, nature says, let's break the rules. Boom! The charge leap across the resistance. Then, sudden jump turns the electrical energy into light and sound, which we call as lightning and thunder. And if no clouds are nearby, the charges strike the ground, a full lightning strike. To protect ourselves, we use lightning conductors, tall copper rods attached to buildings. Why copper? Because it's an excellent conductor. Why tall? So the lightning hits it before hitting your roof. That copper rod is connected to the ground, and the earth, being a giant charged sponge, just absorbs it all, like adding one drop of water to an ocean. But remember, if you are the tallest object standing during a lightning storm, the lightning might choose you. So don't be a hero, get indoors, avoid trees, keep metal objects away, and turn off the electronics during the storm. Oh, and ever wondered how a powerful lightning is? One strike can carry up to 1 billion volts of electricity and reach temperature 5 times hotter than the sun's surface. Yeah, that's not something you challenge with a selfie stick. You might ask the million-volt question here: if lightning has so much power, why aren't we storing it and using it? Lightning releases around 1 billion joules of energy in one big burst. That's like powering 50,000 light bulbs. But it comes down from the sky in a fraction of a second. Wild, chaotic, unpredictable. And we don't even have spoon big enough to catch it. Okay, not exactly spoon. What I mean is storage system, conductors, batteries. Even if we could build a storage tank for it, lightning strikes randomly in different places with different voltages. You can't just keep a giant power bank waiting on a hilltop like, come on baby, hit me. And there's more. Capturing lightning safely requires super tough metals, advanced lightning rods, precise timing circuits, and storage system that won't just explode when hit by millions of volts. We are talking about millions of volts in milliseconds. That's like trying to drink a tsunami with a straw. So, the real reason we don't store lightning, it's not because we don't want to. It's because we haven't yet cracked the tech to do it safely, affordably, and predictably. But who knows? Maybe one day, someone from your generation, sitting with a silly science project, will invent a way to say, "This bottle, oh, it just stores lightning." Until then, we just watch it flash, respect its power, and stay indoors like smart humans.